Hello and welcome back to another video in my walkthrough series of the Cicada Detroit ARG. In this video we will be covering puzzle 32, so let's dive in. Alright, puzzle 32, we see here that we have an image of Caesar with some interesting colored stripes in the background, and then we have a spot asking for a password. And now if we save this image, we will see that it's called the die-is-cast.png, that being an obvious reference to this quote from Julius Caesar. He of course said it in Latin, but it's not really important at the moment. So back to the image, we see a lot of interesting colored stripes. And now we're going to look at these colors using the image color picker tool from htmlcolorcodes.com. We'll upload the image. Now we can drag these little circles around and see the different color codes. And one important thing we'll notice is that these stripes are homogeneous. The color is exactly the same through the whole thing. There's no variation within a given stripe. So this first stripe is hex code 777B76 the whole way through. This one here, for example, is 62, 74, 70, 61 the whole way down. So now it's pretty safe to assume that that is significant, that these colors aren't by accident. If you take the hex codes of all of them, you'll get something that looks like this on the top here. These are the hexadecimal color codes of each column in order. Now there's a pattern here that's easier to notice if you add a space after every other one. So you'll see that every one of these starts with either a 7 or a 6. And if we convert these values into decimal instead of hexadecimal, you'll see that we have a very tight grouping of numbers here. The smallest number is 97 and the largest is 122, which means we have a range of 26 values. Now you can probably see where this is going. These are going to be letters. Now if you're not familiar with what these numbers are exactly, they are the decimal ASCII values. If you look at an ASCII table from ASCIIcode.com, you'll see that 97 is where lowercase a appears, and 122 is lowercase z. So we're looking at a set of letters from A to Z in ASCII. Now we can use any one of these representations to convert this into ASCII. I'll take the hexadecimal value since that's what we got straight from the image. We will go to Rapid Tables Converter and we will use the hex values. We'll paste them in and we'll see an ASCII text string. Now, this doesn't look like any text yet, but the fact that all of these lined up with letters is a pretty strong indicator that we are on the right track. We'll take these values and we'll go to decode and see if we can identify what type of cipher this is. We'll paste in our ciphertext, hit analyze. And we'll see that the top result is a Phillips cipher. But that can't be right because that requires a grid, and we don't have any grids. Let's look back at the list. Now, unfortunately, that's our only strong match according to decode. There's other ones, and you could try them. But instead of just brute forcing this, we're going to use a more targeted approach and use the clues given to us on the page. We have an image of Caesar. The file name is a quote from Caesar. There's a good chance we're looking at a Caesar cipher, so we'll try that. We'll paste in our text. We'll try a brute force decryption with Caesar. And none of these look like English. However, if you look closely at the first result here, you'll start to see words appear in this. So you can see PSWD, like maybe password with the vowels removed. EQLS equals SVNTY 70. You can see where this is going. I'll put the whole text up on the screen. Okay, so here you can see our original ciphertext. When we decoded it using a Caesar shift of -19, now 19 is not randomly picked either. The host of the game, XIX, is Roman numeral 19. And then if we add spaces to that, we can see that we actually have words here with missing vowels in most of them. So we have password equals 75, so on. I've spelled out the full words here. We have password equals 75 multiplied by 6,000 plus 45 minus 77 with letters A to G at the end. Or in other words, you can write it out as a math equation. 75 times 6,000 plus 44 minus 77. If you put that in a calculator, you'll get 449,967, and then we need letters A to G, A, B, C, D, E, F, G at the end. We'll take that string, we'll go back to the page, put that in as a password, hit submit, and you see that we have progressed. And now it says add to brute force. Yes, you're allowed. We have ftp.cicada.id, a username of C313, and a password mask of a capital C followed by 1, 2, 3, 4, 5 lowercase letters. So now there are two things we need to do here. First, we need to create a list of all passwords that match that mask. And second, we need to take that list and attempt everything on that list against this FTP server using the username C313. And side note, C313 is, again, Cicada Detroit, the C for Cicada, 313 being the area code for Detroit. So, first step, we need a list of possible passwords that match this mask of a capital C followed by 5 lowercase letters. One way we could do this is with the mask processor from Hashcat. I'll put an example of the command up on the screen so you can see what it looks like, but I'm not actually going to run this right now. If you did run it, you would get a list of 11.88 million passwords, and you could use that. But that would be a lot of passwords to try. We can take a more targeted approach to this. Instead of using everything that matches a pattern, we could instead make an assumption that what we're looking for is a valid English word. And only look for 6-letter English words that start with a C. And in order to do that, we can use Merriam-Webster, Word Finder, 6-letter word starting with C. And you'll find that there are only 2,000 of them, specifically 2,138. And what we can do here is we can just copy and paste all of the words from this page. So we only have 5 pages of words, so this won't take too long. We'll take the first set, paste those into Notepad++. We'll go to the next page, and we'll repeat this until we have all 5 pages. I'll skip ahead so you can see what that looks like when we're done. Okay, we now have our full list of 2,138 words. Now we know that the first letter needs to be a capital C, and the last 5 letters are all lowercase. So the first thing we want to do is we're going to convert all the letters to lowercase, and then we'll just capitalize the first C. So I'll select the whole thing. We'll go Edit, Convert Case to Lowercase. Now everything is lowercase. Now I'll use the Find and Replace tool, starting at the top. Do Control F, switch to Replace. We will set the search mode to Extended. In this case, a /n means a new line. So that way we only are going to match on the first C. So we'll do /n lowercase c and replace that with /n uppercase C. So this will match the new line followed by a lowercase c. So we can say Find Next and then Replace. And it keeps working on the list, replacing each lowercase c with a capital C. We'll replace all to do all of them. That'll get everyone except for the very first one because there was no new line before that. So we'll do that one manually. And now we have our list. 2,138 words that match the format that we're looking for. And if this doesn't work, we can always go back and try the full list of 11.8 million words. But this will be a much more targeted start. Now there's actually a second assumption that we can make that will reduce this list even further and make this whole thing faster. And of course, if this assumption turns out to be wrong, we can always step back and expand our search. But we know that the word we're looking for, or that the pass we're looking for, starts with a capital C followed by all lowercase letters. So we can make the assumption that what we're looking for is actually a proper noun. So I'm going to undo the changes I made here and set this list back to the exact format we got from Merriam-Webster. And now we're going to replace every word that doesn't start with a capital C by default, thus eliminating all the words that aren't proper nouns. So for this, we'll go back to the Find menu, go back to Replace. We will set the search mode to regular expression. We will set the find case to a lowercase c, a dot, and then a 5 in brackets. This means a C followed by 5 of any character, and we will replace it with nothing. Make sure that the match case option is selected, and if you hit Find Next, you'll see that it finds the first word. We can hit Replace, it disappears. We keep doing that down the list. We hit Replace All, we'll see that all of the words starting with a lowercase c have been removed, but the capitals are still there. But we do have a lot of white space in this file, so now to get rid of that, we'll go to Edit, Line Operations, Remove Empty Lines. And now we have a much smaller list of 165 words to try. Now, as for how we're going to try these words, we will be using a tool called Hydra, which you can download from GitHub. This tool runs in Linux, and you can use any of the password lists we just talked about how to generate. You can either use the one from Mask Processor, which was 11.8 million options. You can use the list of English words that match the mask using Merriam-Webster. Or you can use the refined list of only the proper nouns. If you try the full list from Mask Processor, it'll likely take you a few days to run through it. If you take the shorter list from Merriam-Webster, you can do it in a matter of minutes. If you take the really small list of just proper nouns, you can crack this in a matter of seconds. Alright, so to use Hydra, we just type the word Hydra, and then the dash lowercase l option to specify our login. In this case, our username is lowercase c 313. Then a capital P specifies if you want to use a password list for the brute force attack. I've named my file passwords2.txt. Then we list out the URL for our server. We're using the FTP protocol. So FTP : and then ftp.cicada.id is our domain. And then we want to do this as fast as possible, so we're going to request 64 threads, which is the max that Hydra allows for attacking FTP. And then we can just hit enter. Alright, now you can ignore the warning about a restore file. That's only there because I killed the previous attempt that was going to take 232 hours. So after a few seconds, that'll disappear, and you'll see that it's doing a max of 64 tasks per one server. Overall 64. There's 2,121 logins to try. It's doing 34 of those per task. It says it's attacking the FTP server at ftp.cicada.id on port 21, which is the standard port for FTP. I'll skip ahead a minute so you can see what's happened. Alright, we're 1 minute in. It says that the status is 819 tries per minute. That we've done 819 in the first minute. There's 1,316 left to do, and it's estimating that'll take an additional 2 minutes. We'll skip ahead again. Alright, and we'll see that it actually finished after the second minute. We see that it says 1 of 1 target successfully completed, 1 valid password found. And it says that the password is Cybele, capital C, then Y-B-E-L-E. Hi there, editing mode John here. As I'm working through editing on this video, it occurred to me that there might be another way. It just so happens that the password also appears in rocku.txt. So if you didn't want to generate a password list at all, a fourth option would be to just use this pre-existing one, which in this case happens to also have the password. Now, this file contains over 14 million passwords, so this would be by far the slowest approach, but it would save you the time of having to create your own password list if you didn't want to do that. So, fourth method, slowest, but there's another option for you. Now, no matter which route you took, Hydra will eventually tell you that the password is Cybele. So now we need to go to the terminal and connect to the FTP server. To do this, we'll write FTP, and then the subdomain FTP, and then cicada.id, hit enter. It asks us for a username. We'll type C313, and then for our password, Cybele, and it says well done. The next puzzle can be found at www.cicadadetroit.com/hilaria-ensues325. We'll take that URL. We'll go there. And that takes us to puzzle 33. Alright, so that was puzzle 32. We'll pick it up next time with puzzle 33. As you can see, there's a few ways you could approach that one. If you use one of the methods that I used, let me know. If you use a different method, I'm curious to know about that too. And as always, thank you for watching, and I'll see you in the next one.